Hi, welcome back to my channel. Hope you are doing good. Today I'm going to talk about Kubernetes storage provisioning class, persistent volume time, the flow of the pod access with respect to any storage path, how we can attach the disks which can read by pod and perform certain activities. So let's jump in. So what is storage? Suppose if you have a laptop or a desktop, you have a disk and RAM and all those things. So you install the operating system which is going to reside if it is a Windows C drive, and you partition D drive, E drive for keeping your files, whatever it is. Like that, if I am running an application which is a pod based, that is container based, application, how that container can access the actual storage path data which is for the application purpose. So that is the agenda of any of the application, right? So how we can basically create a storage, how we can access the storage that is called a disk from the pod. That is the exercise which we are going to talk about. So basically Kubernetes real-time exercise which we are going to use the following kinds: storage class, persistent volume time, pod. Nginx web server is the sample for the demonstration, and service type is node type. We have seen in part 2, 3 and 4 about service types. You can read it if you want. Kind type storage class. A storage class provides a way for administrator to describe the classes of storage. As I said, the storage provisioners are different vendors. Azure will be there, local disk you can point, Google you can point, VMware disks you can point, like a different types of provisioners are available to handle it. Each storage class specifies specific fields when you are defining the kind, provisioner, parameters, reclaim policy, blah, blah, blah. Okay. So we can see that. And persistent volume. Persistent volume is basically, it is a piece of storage in the cluster that has been provisioned by an administrator using the storage class, and which can either dynamically also expand the storage if it is required. Yes, it is possible. We can have that. We need to define the storage class. That storage class is going to be consumed via the persistent volume. This persistent volume just defines where is the path, what is the size of the path, what can I do, whether I can read only or I can write only, read once or read many, likewise, which will define how consume the defined path, which is essentially the responsibility of volume climb. Persistent volume climb is a request for storage by user. It is similar to a pod. Pods consume node resources, and PVCs consume PV resources. How your pod is going to consume the Kubernetes node related resources? The same way, how to consume a persistent volume using a persistent volume climb. That is what it is. That is a resource. PV is nothing but a resource, the storage resource. Okay. So this is how the high level flow will happen. You have a different storage class provisioners: local, vSphere, Azure File, NFS, GCE, likewise. By using the storage provisioner class, we define a persistent volume, okay, based on the variety of types. This persistent volume, we are going to climb it using PVC. This PVC we are going to attach to a pod. So pod will understand attached PVC, and then that can be exposed. This pod is running on 8080 port, on 80 port, which cannot access outside. So I need to have a service which of type NodePort 80, which is going to call this pod, and I'm using a web browser to get access of my 80 port. I have to do a port forwarding from my Windows machine. So this you can ignore it. I mean, for a demonstration purpose, I had to go with this route. So until here we are good. We can go ahead and access the provisioned port. But for a mini kube which is running in my local, to access from browser, I have to do the port forwarding ideally. So this is how my physical architecture, which is running the real Kubernetes engine, Windows host operating system, where I am running a virtual box which contains a Linux guest operating system. Here I enabled Kubernetes port forwarding 8000 to 80 port, and Minikube is one of the hosts where the Kubernetes engine is running. Here I am running a Nginx web server for the demonstration. If there is a content change, whether the content is being reflected on my web page or not, for demonstration purposes. So I can use different types of clients. As I said, Windows machine with the port forward, browser, or CURL based, but I wanted to show it through a browser. Okay. So this is the physical architecture, and these are the prerequisites. Please read. These are self-explanatory for understanding of the PVC, PV, and storage classes. So these are the reference links. Now let's jump into the hands-on session. So now let me clear that. So I have a Kubernetes which is running. As I said, this is the namespace. I'm going to look up, is there any resources already running in my namespace? I see that there is no resource available in this. So I can show you how to define the provisioning classes. Okay. Now I am considering, so this is how I'm going to define a storage class. This is the signature we have to use from the version, and metadata local storage, the name of the storage class, and the provisioner who is provisioning Kubernetes IO, no provisioner. So here, this is the locally I am maintaining. Because of that reason, I am specifying no provisioner. And volume binding mode, wait for first consumer. That means whenever a first consumer connects to the PVC, that means it starts consuming it. So that is the representation of the storage class. You need to define it. Now let me define a storage that is persistent volume. So now if you look at it, this is the version v1 persistent volume. The name of the metadata is test local PV is the name for local PVC. I'm not going to use it here. If you look at it, local path, node affinity, this is the one variety of syntax we can use it to test it. Or I have another one, host PVC based. This is a little bit different because that is going to rely on the storage class basis. So persistent volume, but I am using a host PV based application. Specification capacity, I am specifying storage is 1 GB. Access modes read write, and persistent volume reclaim policy retain. Keep that, do not delete the content. Storage class name is local storage. I am specifying host path. This is the host path. That's the reason I named it as host PV. This is local path. That's the difference. You can read out later. Let me keep this path readily so that I can reuse it. So now this is how we are going to use. I am going to use host PV. Now let me clear this and define local PVC. This is the one I am going to use it. Persistent volume client, PVC means. This is the version, and test PVC name, access modes, read write mode once. Storage class is local storage. Resources request storage is 1 GB. So this by local storage with the no provisioner, which I specified, that means whenever there is a first client comes from the storage provisioner, that client will be going to consume and will be mounted. We will see that all the details. Now, who is the client? The pod. Pod is the client. So as I said, I'm going to use Nginx is the web server. So if you look at it, version v1, kind pod, the metadata, this is the label I'm defining, and this is the container specification I'm specifying. And here, if you keenly look at it, volume mounts. So by default, Nginx is the content, static content hosting path is this, wherein whenever we place any content, this content will be read by the Nginx and display for the web server whenever we access it. So let's keep that path. And now you see how we are going to mount the content which I am placing it into the path which I have shown in host-pv.mount previously. Okay, so here I am defining a mount, volume mounts going to map up with the volumes with the same name. I'm specifying persistent volume climb. That is how the diagram which I have represented. And what is the name? Climb name is test PVC. If you look at it, test PVC. So this is how the order we have to deploy the manifest file so that it will be available. Now let us look at it, how I am going to access it, my service. So now I am using service type kind of NodePort, and I'm specifying a selector of the node label that is with the pod. Whatever the pod has the name label, this is the one which is going to map and map the content and get the access. And protocol TCP 8080. So this is all about storage class SC, PVC, PV. Okay. Now let me host it. Kubernetes -n. This is the real time. Okay. I'm going to create a resource that is local volume. First, I'm creating a local volume. Okay. I forgot to specify the file name. Create a resource -f. So now if you look at get storage class, that means now I can see there are two, but this is a standard default one which is coming from the Kubernetes. I did not create it, but I have created local storage is this. Now I'm going to use host PV. Now I can issue a command to check PV is created or not. So now I can see that persistent volume created, read write, retime status is available, which is mapping with the storage class is that. Now let me clear the screen. Now go ahead and host local PVC. Local PVC. So this is the climb one. It is created. It is saying, let us see whether status is consumed or not. Now I can see that persistent volume climb, the test-PVC is the name, which is status is saying as a pending, because according to the instructions of the storage class, which is local storage, wait for the first consumer. So until then, the status will be in pending status. Okay. Now let me go ahead and deploy a pod to consume the storage resource. The pod is www. Now pod is created. Whether it's created or not, we wanted to see it. Now you can see my storage class is available, persistent volume is available, and persistent volume climb also available. Now you see the status, it is bound. That means it is properly mapped to the storage by the pod. That means whatever the content which I will place it, I can able to get it. So now my pod is up and running. It is stating for me. So let me go ahead and check the log for the pod. I issue logs www. So this is how the pod has been started. Okay, it is getting the checksum, all this, the entry point, whatever, blah blah. Started processes, resource limit, and process 3031. This is successfully up and running my Nginx server. Now I need to host it two paths, right? So as I represented before, this is the path Nginx pod is going to use it, right? The content. If I'm going to place some content here, right? So now let me go to the Minikube host. So this is the Minikube host. If you look at, this is the name of the host, Minikube, where I supposed to create make directory, because this path is by the admin, so I wanted to go there sudo mode. So that means now this path has been created. If I can go ahead and issue a command, I can see that. So volumes is there. Now I wanted to grant permission to all the people to access this. chmod recursively I specify 777. So now you see the mode has been changed from this to this. That means everybody, user, group, others can able to access it. Now what I am going to do is I am going to test my application. Let's close this. Let's use a different browser. Let me go ahead and check this. So here it is not able to access because the port forwarding is not has been enabled. Now I have enabled port forwarding. Okay, it is saying that there is no service found. That means I did not provision while creating. Okay, I created up to pod. Now I need to create a service. Let me go ahead and now service also ready. Now let me try to issue that command pwwsvc service. Now my service also running, that is a NodePort, and the service port is 80. So now let me do port forwarding so that I can able to access it from my Windows provisioning machine. So now what I wanted to do is, now let me go ahead and check whether at least I can able to access it or not. Yes. Now you can see that I'm able to access it. The content has been forbidden. This is the Nginx which is running as a pod. Now there is no content. As I said, this is the default location where I supposed to place the x.xml, HTML, so that I can able to retrieve it. But pod is running. I don't want to put it inside the pod. I wanted to keep it data here so that the content can change easily for my application. That is how we build, right? If you want to change your content on the file system, that should reflect it. That's how the pod going to consume the storage. Let me go here and slash data volumes pv1. This is the path. I'm here. Now there is no files which I generated. Now I'm creating a file echoing this is testing. I specify that index.html. This is the standard notation the document will be used by the web server, that is Nginx. Now I have placed a content. Now I wanted to show you whether the content is going to render. This is testing. That means I did not place it in the actual container, that is a pod where the content can be placed, right? So now what I'm going to do, I'm going to add, come on, updated, I specify. So I'm placing it on the my mount system on the host operating system that is actually mapped in the pod, right? So the pod is mapping and the content is getting updating automatically. See, this is testing. I'm appending to my file. That's the reason you will see that content index.html. So this is testing, this is testing. Here you can see as a 2 lines, but as a web content, it is sitting on the single line because I did not use any break in the HTML content. Okay. Now this is how this file will be automatically mounted as I have represented before. The cat local, not local, let me clear this, cat www.yaml. So here I am specifying the persistent volume climb is this, and here by default the content will be mapping with respect to the PV which I have defined. PV has the path mapping. So here this is the path where I am placing the content on the host. So that content gets updated automatically whenever whatever I'm changing it here. So now I just say only I want updated to. That means I'm overriding the content. Now let me go ahead and issue. See, only updated 22, previous content has been get rid. This is how your pods can able to communicate with the storage disk and able to retrieve the data as you need as part of the application. That means I have a storage provisioner, Kubernetes one, first consumer when it gets, it is going to access it. I defined a persistent volume. I defined a persistent volume climb. Whenever first consumer comes, it will be bound to that client when it can be accessed. That is the pod, that is Nginx, and the service exposed, and I'm changing the content on the host file system. Automatically the Nginx is being taken the data. That is how the data has been rendered. Okay, that's all the real-time exercise. Hope you are learning storage classes, persistent volume climb. Like it, share it, and subscribe it. If you have any comments, please post it. Until then, thank you. I come up with a new video